Solve another problem here. Cosine of 2x plus 3 sine of x minus 2 equals 0. Basic strategy I like to have is to see if I can get it all being the same terms, all sines or all cosines or what have you. May not always work, but that's a great place to start. Cosine of 2x plus 3 sine of x. How in the world can I turn one of those functions into a cosine or a sine? Maybe you recognize that right there. Or maybe you just scanned your list of emerging and growing expressions and you remembered that as, well, that's a double angle identity. So cosine of 2x, well, that also equaled the same thing as 1 minus 2 times the sine squared of x. And then I can keep going, 3 sine of x minus 2 equals 0. From there, let's just go ahead and just do some work. So I have minus 2 sine squared of x plus 3 sine of x. 1 plus a negative 2 gives me a negative 1 equals 0. Starting to have a quadratic form. Let's get a leading positive coefficient. So let's multiply both sides by a negative 1. I have a quadratic now that I can solve, or well, not solve, I can factor. However, I'm still not quite good at factoring this by looking at it. I have to kind of rewrite and look at it from this perspective. Maybe you guys are great at factoring this one, but I'm not. So I'm going to look at factoring this, which I can do because I remember practicing those like crazy before. So that factors down. Was that a plus 1? Nope, that's a negative 1 right there, folks. Negative 1 and a negative 1. Let me double check. First times first gives me a 2u squared. Outers, last times last gives me a positive 1. The inners is negative 2 plus a negative 1. Yep, that's how that one factors. Boy, I'm so grateful that my previous teachers made me factor a lot. All right, so now let's factor this one. It's the same. So I have 2 sine x minus 1 times sine x minus 1 equals 0. This first term, set that first term equal to 0. 2 sine x minus 1 equals 0. And the second term, sine of x minus 1, set that equal to 0. Solving this down, I get the sine of x equals 1/2. And the sine of x equals 1. So let's look at this one first. That one is a little bit easier for me. What values or what angles produces a value of 1? And that happens at where x equals pi halves. Because I know that the sine of pi halves equals a 1. So there's one value that I have that's within this particular range. I know that's the only multiple of this particular value because if I add 2 pi to it, it's just going to shoot me off beyond this particular range. So that's the only value that I have there. The other one is sine of x equals 1/2. What values produce a positive sine of 1/2? And that was where x equals pi 6. And another way to look at that is the sine of pi 6 equals 1/2. So, only values? No, because I have a positive 1/2. I know that there's one more quadrant that produces a sine of positive 1/2, and that's in the second quadrant. Yep, the second quadrant. To get the value of the second quadrant, I'm going to take pi minus this acute angle. And that's a 6 over 6 pi minus a pi over 6 pi, or pi over 6 equals 5/6 pi. So that tells me that also the sine of 5 pi over 6 equals 1/2. So that's my next solution. So I have 5/6 is a solution, pi 6 is a solution, pi halves is a solution. So those are my 3 solutions to this equation that fit within that particular range.